and solve some of these chemical kinetics equations. So I have this equation or this question on the table saying that 50% of the first order of the reaction is complete in 23 minutes. Hence, the question is saying that calculate the value of K. The question you should ask yourself, or things that you're supposed to note them down, is that what is this order? Is it a second, third, or zero? We're talking about the first order of the reaction. Then what is the time taken there? We're then talk about 23 minutes. Since 23 minutes is required for the reaction to reach what? 50 minutes in first order of the reaction. So we need to find the value of K. How are we going to do, or how are we going to go about it? So before going any further, write your data here. What's your data? Your time is equal to 23 minutes. Then what I'm trying to talk about there, first of all, you are trying to look or to find the value of what? K. And that you should show, or you should try to show the examiner to say, this is what I have on the table. So what I'm going to do, note that mostly it is recommended that you should try to convert this 23 minutes into seconds. Or in say concentration always deal with what? Second, mostly. So what I'm going to do, I prefer me to convert it into what? Into second. As usual, not to say 1 minute is equivalent to what? 60 minutes or 60 seconds. And how many minutes do we have? I've got what? 23 minutes, which is equivalent to what? X there, as in nothing. Then what will happen there if we have that? We're looking for value of X there. That means to say X times 1 there is X. What is 60 times 23 there? What are you going to have? If you multiply 60 times 23, you're going to have your X as 138 seconds. So in 23 minutes, we have 1,380 seconds. So in this case, this 23 minute is equivalent to 1,380 a second. Now, ask yourself, what was that order? That order, it was the first order of the reaction. What I trying to talk about? Possibly there, the questions are about calculating the half-life, the time taken of the maximum concentration to reach what? Original value. That's the only way you can try to calculate the value of K there. So what is that the value of K? We're going to have this formula. What's a formula for first order of the reaction? It is 1 over 2 as the time taken there, half-life, is equivalent to 0.693 over what? K. So in this case, what you're trying to look for, you're looking for value of K. What's your half-life as in time there? You have 1,380 is equal to 0.693 over what? K. Then you're looking for value of K, hence try to find the value of K. What is K times Z? That is 1380. K is equal to 0.693. You're looking for value of K, you say over what? That both sides, even this side, you have 1,300 and what? 80. Even this side, 1,300 and what? 80. So this one gone. What's your K? My K is equal to, punch it on your calculator. I advise you to punch it twice. You might make a mistake there. So 0.693 divided by 1380, you're going to have 5.02, and less of the decimals there. Possibly you can try to convert it into decimal places. So I'm going to have 5.02, and the third number is 1 there. So we cannot try to round off because we have that which is taking place. So which is molar per what? Per a second. And the reciprocal there. So we have that as a rate constant there, molar per second, or we can say more per liter per second. Those are the units of what rate constant that we have found in this case. So this marks the end of finding value of K. So let's try to solve the next problem. We have this equation under the first order of the reaction. A certain first order of the reaction has half-life for 40 minutes. Hence, calculate the rate constant. How much time required for this reaction to be 75% completely or complete? So what I'm going to do here, You should not know that what order reaction are dealing with. We're dealing with first order reaction. What time are we dealing with? We're doing 40 minutes, supposed to be converted into seconds. We are looking for value of K, and we need the time which is required to reach 75%. So pay very much attention here how far and how we're going to go about it. Shall we? Let's go. Write your data there as usual. You say, what's your time there? Your time in this case, it is 40 minutes, which is equivalent to 1 minute is equivalent to what? 60 seconds. And in this case, you have 40 minutes there, you have x here, trying to do some multiplication there, x times 1 there, it is x. Then 60 times 60 there, get your calculator and try to punch there, it is 60 times 40. Try to punch there, say 40 times 60. What I'm going to have there, I'm going to have your x as 2,400 seconds there. So those, that is your time. Then in this case, what I'm going to do next, you're supposed to find the value of what? K. And once you find the value of K, and that's your A, then you're supposed to find the time taken required for the reaction to reach what? 75%. So, what I'm going to do, as usual, it's the first order of the reaction. So before going further, you try the half-life formula to calculate the value of K, which is time half-life there is equal to 0.693 as usual, divided by K is equal to, what's your time there? It is 2,400 seconds is equal to 0.693 over what? K there, 1 minute, and do some multiplication there. K times that, it is 24. K there is equal to 0.69 what? 3 over 24 over 24. Divided by K, you try to cancel them. What I'm going to have in this case, you're going to have K is equal to, get your calculator as usual, you might make mistake punch twice, 0.693 divided by 2400. What I'm going to have, if you try to divide 0.693 divided by 2400, you're going to have 2.8 in two decimal place, possibly the third number there is 7. Once you get it and round off to the second, which is 8, you're going to have 9 times 10 exponential negative what? 4. As usual, how are you going to put up the units? You should try to calculate in this case. You say, what? M there as molarity there over a second times, you're dealing with order of the reaction, should I say first order of the reaction. So it is the same thing there, which is M over what? Should I say 1 over M there? But if it was a second order reaction, we would have put a square there. Zero order reaction is equal to what? Constant there. So what I'm going to do here, I'm going to say M times M there. Before going further, what is M times M? It is M squared there. M squared. What is 1 times M times S there is, or should I do this? If I go any further, you say just cancel them, not multiplication, just cancel them. So this M goes to that M, or in this case, you say M times 1 there, it is M. What is M times S there? It is what? MS. So this one gone, hence I'm going to remain with what? The reciprocal of 1 there. So hence I'm going to have a reciprocal of what? S there as your units of that order of the reaction. So we have K there. So let's try to check question B. Shall we? Let's go. Hence in this case, B is saying that we calculate how much time taken is required, or how much time is required to reach the reaction of 75%. How much time required for the reaction to be 75% complete. What I'm going to do there before going any further, first of all, you're looking for the value of T. Hence, we want to utilize the half-life formula to calculate the value of what? T as in time taken, which means we're going to get back to 40 minutes. So what I'm going to do is the first order of the reaction, hence utilize the what? The formula of integrated lateral, which is in is equal to the concentration of A is equal to negative KT plus the in of initial concentration of A. As usual, what I'm going to do in this case, possibly looking for value of K or a value of T. So correct items there say when negative KT, classical sign, we're going to have positive KT is equal to the in of initial concentration divided by, minus one's classical sign to be the in of concentration of A. So KT is equal to the in, as usual, like what I said, under logarithm, you say the log of B base A minus the log of C base A. Same applies with log of BC over C base A. So the same thing that we're going to do here, we're going to have concentration of, or initial concentration of A divided by the concentration of what? A there. And what will happen in this case? I'd like you to hold on K even if you're looking for value of T. And before I go any further here, make sure that you have a data somewhere there which characterize that what's your K? What's your K? My K is this. Then what next? Do you have time? Possibly you don't have time. What's your initial concentration? Your initial concentration is what? 100. Right? Now you should be asking yourself why initial concentration is 100. I talk about 100%. In this case, you agree with me if you have reaction A reacting with reaction B, under chemical kinetics, you're going to produce what? Reaction what? Reaction C plus D. That means that what is possibly happening there is that, as you know, always the reactant do disappear, in the product always what? Appears. So this is concentration of A and concentration of what? B. They're trying to do what? They're trying to disappear. Then the concentration of D and C as product, they're trying to do what? To appear. So what will happen there? They're starting from 100 there. So initial concentration is 100 of the reactant. Once they try to disappear later on, we give the product there which are starting from down there. And possibly that means that if the reaction has reached 75%, if the reaction has reached 75%, that means, the time taken on the reaction to reach 75%, that means the time, or let me say the percentage that has, this reaction is going to cover, or reaction that has already covered so far, it is 25%. How and which way? Because 100, as you know, to say the percentage equivalent to 100 minus the initial, or where I say the remaining percentages are for it to equivalent to 100 from 75, it is what? 25. So that means to say it will be 100 minus 75, which is a variable percentage, the percentage which are required, then it's equivalent to what? To 25%. That means here we're going to have what? The concentration as in is equal to what? 25%. So come here, you say in, open up, what is the initial concentration there? It is 100. Divide by, what is the concentration I'm dealing with there? I'm dealing with 25. And I'm going to say KT is equal to in, open up, what is 100 divided by 25? You're going to have 4 there. You come here, you say KT is equal to, what is the in of 4 in that case? So the in of 4, you open up, you say in, open up the parentheses there, you close, then what I'm going to have, you're going to have 1.386. I put it into decimal places. The fourth number there is 2, which is equivalent to nothing because there are 5 there. So now in this case, I would like you now to take into consideration the value of K. What was the value of K? That means so wherever you have K, you replace with 2.89 times 10 exponential 4. T there as in time, then it's equivalent to what? 1.386 there divided by 2.89 times 10 exponential 4 divided by, we are dividing both sides, 2.89 times 10 exponential what? 4. So this one and that one goes. What I'm going to do, allow me to clear that side so that I can have space. Hence, what will be your time? Your time is equal to, you should divide 1.386 386 divided by 2.89 times 10 raised to negative 4. You're going to have 4.8, because if you try to round off, possibly you're going to have that the third number or second number is equal to 9. If you round off to the 8, it goes to 7. So now in this case, we're supposed to round off this into possibly supposed to round off that into not 4.8, not 4.8, pardon me please, it is 479.5.8. Possibly you can try to round off into exact number. We're going to have 479. It will be what? Is 6 seconds. So in this case, the time required to reach 75%, it is 4,796 seconds. This is the time that is required to reach, or the reaction to reach what? 75%. This marks the end of chemical kinetics problem. Hence, I'm going to leave you with this homework so that you can try to solve the chemical kinetics. Okay. So make sure that you solve this one as your homework. So you have determine the value of let rho, find the value of K. What will be the initial rate for the experiment with the chloride oxide there, which is initial concentration of 0.175 mole per liter. Then we've got hydroxide ion there, 0.0844 molar or mole per liter. So I need these solutions as soon as possible, please. So make sure that you solve them adequately and also with solutions. Thank you very much. See you in the next episode. Thank you.